Hi, my name is Lindsay, and I am a senior undergraduate biology student at the University of Central Florida. And before I kind of dive into the details of my project, I wanted to describe a scenario for everyone. So I want everyone to picture a neighborhood. It could be your childhood neighborhood, the neighborhood you live in now, just any neighborhood. And then imagine tomorrow a big tornado comes through and destroys all the houses in that neighborhood. Well, because of the damage, you're most likely going to get up and move to a new location. But say a couple months later, they start rebuilding those houses. Are you going to return to the neighborhood? Are the people and the dynamics of the neighborhood going to be the same? Well, these are the questions I was thinking of, but with oyster reefs. So, oyster reefs have experienced a lot of damage over the years, but luckily, restoration projects are being implemented to try and help with that. So, similar to the neighborhood example, I wanted to see if infaunal organisms, which are these little microscopic organisms that live in the sediment, if they will come back to oyster reefs that have been restored, and if those infaunal organisms and oysters will function the same way that they did originally. So to do this, I tracked infaunal taxonomic groups on restored reefs. And with what I found, I compared those values to pre-restoration infauna as well as to infauna on live and dead reefs. So to do this, I headed out to Mosquito Lagoon, which is known for implementing a lot of restoration projects. And if you make your way up to the flow chart in the top middle of your screen, you can see that we first collected samples on dead, restored, and live reefs, and then we sieved them. And we replicated this entire process before restoration as well as periodically after restoration. And then once we had our samples, we took them back to the lab and we sorted the infauna into one of the 6 groups listed on the flow chart. And then from there, we ran a bunch of tests. So if you make your way to the results section, the first graph in the results section, this is a NMDS test, which shows us the similarities of the samples based on what reef they were collected on. So essentially, the similar the shape and the more overlap of the shape, the more similar the samples are. So visually, we can see that the infaunal communities on restored reefs became more similar to live reefs over time and less similar to the dead reefs. If we make our way up to the top right corner, this is an indicator species analysis test. And what this shows us is it shows us the measure of association between a species and a reef type. So for example, a polykey and a live reef. And what we found is that all the species in that table are actually statistically significant indicators of the associated reef type. So what's cool about all this data is that after 2 years, it's possible for a restored reef to provide the same or similar infauna or food sources that live reefs do. And this is really beneficial for organisms higher up on the food chain. So for example, Mosquito Lagoon is home to a lot of wading birds. And these wading birds actually eat the infauna on the oyster reefs. So if restored reefs and live reefs have similar infauna, then those restored reefs are likely going to attract more wading birds, which is really healthy for the oyster-based ecosystems. Overall, we found that it is actually possible to design restored reefs that can recover those oyster-based food webs through the recruitment of infauna.